decompose this U into a triangular matrix, which is written over here as U is equal to some matrix is written over there. So let us quickly go back to our this last class. So how did we perform this exercise? Was something like this. This was a system of equation. Here, right hand side we have constant term. So in order to eliminate x1 from equation number 2 and x1 from equation number 3, we multiplied this by a factor of 0.1 by 3 and subtracted it from this equation number 2, first from second, or sorry, this okay. So basically we eliminated equation x1 from equation number 2 as well as from equation number 3 by multiplying this by factor of 0.1 by 3 and this 0.3 by 3. So once we perform this exercise, these factors are also very important. Last time we didn't bothered about these factors, but let us store these factors, and I say this factor is since we are eliminating the this term 2 comma 1, that is second row and first column. So we will denote this by f21. So f corresponds to factor and 2 corresponds to your row and 1 corresponds to your column. So f21 is the factor corresponding to second row, first column. Similarly, f31 was the factor which was used to eliminate x1 from equation number 3. So we will denote this factor by f31. So a similar way we can use this terminology for other factors also. So let us go back to our original problem which we are discussing. So here we can see that this was the upper triangular matrix of this given matrix. So this upper triangular matrix we are representing by U for upper triangular. Now coming on to the factor, we see these were the factors which were used to eliminate this x1 from equation number 2 and equation number 3. Similarly, f32, third row, second column, was the factor used to eliminate x2 from equation number 3. So in the principal diagonal, we have all unity terms, whereas this in off diagonal terms and corresponding to lower triangle matrix, you can see that we have these factors stored here. This is how storage is done in your computer so as to save the memory. So here you can see f21 is this factor, f31 is this factor, and similarly f32 is this factor. So you can see here that one is upper triangular matrix, one is lower triangular matrix. We are denoting this upper triangular and this lower triangular matrix by U and L. So here we can see this LU decomposition of this matrix is nothing but we have combined these two terms, that is upper triangular matrix and lower triangular matrix, here in a single matrix. You can see here. So this is the lower triangular part, that is which contains the factor, and this is the upper triangular part which contains this upper triangular matrix. Okay, So this is called as LU decomposition. Uh, okay, so let us proceed towards the application part of this LU decomposition factor. Okay, so up till now, anything we need to discuss? So if you multiply these two terms, that is L into U, we will get this original set of equation A. Okay, original set of equation A, which was there in equation this slide. Let me show you. This original set of equation was this, and we have multiplied with these factors, and we are storing these factors in a lower triangular matrix. Okay, so if we multiply with the upper triangular matrix with a lower triangular matrix, we'll get the same thing, A matrix. Okay, so the application why we are doing this LU decomposition is that we want to calculate inverse of this matrix. Okay, so this is the matrix 3 cross 3. That is coefficients. We are not considering this your right hand part. We are only concerned about this matrix with the coefficients x1, x2, and x3. So if I write it in a matrix form, it is represented something by this term A matrix. So here A matrix. So can anybody from your class give me the solution of using your this conventional method of getting matrix of this inverse of this matrix A? Any one of you? What will be the inverse of this matrix? And now once you give this, now we will see the new way to calculate the inverse of a matrix, and how the computer's performance is its computation. What is actually going inside the computer to calculate this inverse? Any one of you?
Sir, wait, it's a long process.
Okay, you solve it, make the calculation, give the inverse of this matrix. You perform this exercise. This is a 3 cross 3 matrix. We need to calculate the inverse of this matrix. Okay, Gaurav Kumar. Okay, Raj uh, Kritya. Kumar Raj Kritya. Puneet.
Yes, sir.
Acha, Navneet, can you answer what is A into A inverse? Matrix A into A inverse.
Yes, sir, solving.
No, what will be the this Mrinal, what will be the answer for this
Yes,
if a
sir.
matrix is multiplied by its inverse?
So
One.
identity matrix, identity
Huh?
matrix,
Unitary
identity matrix.
identity matrix.
I.
Yeah, very good. Okay. So if your answer for the inverse of a matrix is correct, then you may cross check it using this A into A inverse is I, identity matrix. Okay, so you keep on solving. You may solve it at a later point of time. So I'll show you, or I'll show the procedure how we use this LU decomposition technique to solve calculate the inverse of a matrix. So we have all seen that this matrix, A matrix, can be decomposed into a upper triangular matrix and a lower triangular matrix. So this is on the right hand side, this is upper triangular matrix, whereas on left hand side we can see lower triangular matrix. Lower triangular matrix contains the factors. So this is a lower triangular matrix and upper triangular matrix. We have decomposed this. Now let us use this technique to compute the inverse of this matrix. So I have this lower triangular matrix, and I have multiplied some term d1, d2, and d3, and I have equated it to as this uh, uh, right hand side with having this first row as unity and the rest of the row is 0. So anyone from your class? Okay, Abhinav, what will be the value of d1?
Sir, 1. D1 equals
1.
to 1.
And what is this lower triangular matrix? Lower triangular matrix, what is this matrix? Or what are these numerical values corresponding to? Okay, so Ayush Agarwal.
Yes, sir. Yes, sir.
So what is this term? What is this in the lower triangular matrix? What is this second
Sir,
row and
D2 is
what?
equals to minus D1. D2 is equals to minus 0.033. Continue.
Acha. And D3? What is the value of D3? Bablu Kumar Patel. Okay, Bunty Kumar Das. What is the value of D1, D2, and D3?
So D3 equal to minus 0.099.
Okay, so you type your answer in this, whatever your answer you are getting, you type it in the chat box, D1, D2, and D3. Let us see how many of you have calculated it correctly. You give Asis all the three answers, D1, D2, and D3. D1, you can see here, there's D1 is your 1. So D2 is also pretty straightforward. Okay. Yes. Kriti, you give all the three answers. D1 is but obvious. You can see it from here. Okay. D3 also. And it depends on your honesty that whether you are solving it on your own or simply looking the answers from what others have written. Okay, Ankit, one more value. Okay, you have given three values. Okay, very good. So this term that is we are getting is 1 and point minus 0.0333 minus 0.1009. This corresponds to D. Now we wish to calculate the inverse of this matrix. Please remember these steps. This is upper triangular matrix, and this is the new right hand side which we are getting. This is corresponds to value of D. So once we solve this for x1 and x2 and x3, so these x1, x2, and x3 will represent the first column of inverse of matrix of A. First column of inverse of matrix of A. In a similar manner, what we did was that a matrix containing the factors, we have written it in a lower triangular form. Then and we are replacing this right hand side with this first term, first row term as 1 and the rest of the term as 0 in order to get first column of inverse of matrix A. In order to get a second column of matrix A, now we will replace this second term with 1 and rest of the terms of row 1 and row 3 will be 0. Again we will perform this exercise. We will calculate this value of D1, D2 and D3 here. We will solve for D1, D2 and D3 but within a new right hand side with that is 0, 1 and 0, and we will get the value of this matrix that is on X and calculate the value of X as this. This is corresponds to second column of inverse of matrix of A. This corresponds to second column of matrix of inverse A. Similarly, in order to calculate the third column of matrix A, what we will do is we will replace this R1, R2 with 0 and third with 1. And we will again calculate the value of D1, D2 and D3. Then we will replace it in the right hand side and calculate the value of x1, x2 and x3. This will give the third column of matrix A, and hence we have calculated inverse of a matrix. This is a typical process for a 3x3 matrix, but your computer handles a 100 cross 100 matrix and maybe a 1000 cross 1000 matrix. So this process, this type of technique is much this space saving as well as time saving for the computer. Okay, which is not possible solving these equations through hand calculations. Okay, so I will repeat once more what I have done here. Please look it carefully. We need to calculate inverse of matrix A. Matrix A is given here. We need to calculate the inverse of matrix A. So we will decompose this matrix into an upper triangular form and lower triangular form. Upper triangular form, we all have seen in our previous class how we do it in to reduce in the upper triangular form. Whereas in lower triangular form, it is a lower triangular matrix containing all the factors which were used to eliminate the x1 and x2 from this our matrix. So in order to calculate the inverse, first step is to take this lower triangular matrix, assume three constant d1, d2, d3, and in order to get first column of inverse of matrix A, we will replace this right hand term with 1, 0, 0. Then we will calculate the values of D, which is a new right hand side. Here we can see this is a new right hand side, and we will solve for the value of x1, x2, and x3, which gives the first column of inverse of matrix A. In order to get the second column of matrix A, we will replace this right hand side with 0, 1, 0, calculate the value of d1, d2, d3. Then again we will calculate the value of x1, x2, and x3. This will give us as second column of matrix of inverse of A. In a similar manner, we can compute the value of third column, this column for inverse of matrix A, and this gives us the whole inverse. We can cross verify all the formula by using the property A into matrix multiplied by inverse gives a identity matrix. Okay. So based on this, you please solve this problem right now. Give the answer. First, reduce it in the lower triangular matrix in a lower triangular form. Lower triangle is nothing but a matrix used to eliminate the terms x1 and x2. Though how we should proceed? What should be our first step?
Ten by three.
Yes.
And subtracting the.
Okay. So this will be our factor. Which factor?
This will be
F2, 1.
yes, sir.
Okay. Acha, who can answer what will be F3, 1?
1/10.
1/10. Okay. So you give this upper triangular matrix and lower triangular matrix. You can share your screen or write in the chat box upper triangular matrix and lower triangular matrix. What you are getting this? You can cross check your answer if you will multiply L part, lower rectangular part, and upper triangular part, you will get this matrix, that is 10 2 comma -1 -3 comma -6 2 and 1 1 5. If you multiply the decomposed part L into and you will get the same matrix. Okay, and this is your upper triangular part. Okay, so Abhijit, have you cross checked it that you are getting same matrix?
Not yet, sir, but
Okay, Krishnam, have
lower.
you cross checked it? You also calculate this lower triangular part?
सर लोअर वाला सही है और सर अपर वाला जो मृणाल भारद्वाज वाला है सर, दोनों मल्टीप्लाई करके आ रहा
आ रहा है वहीं पर। तो अच्छा, अभी
है। यस सर।
नेक्स्ट स्टेप क्या होना चाहिए अभिजीत? व्हाट शुड बी अवर नेक्स्ट स्टेप नाउ इन ऑर्डर टू
सर
कैलकुलेट?
लोअर ट्रायंगुलर मैट्रिक्स में D1 D2 D3 लेके और राइट हैंड साइड में 1 0 और 0 लेना है।
हाँ,
और सर फिर उसके लिए D1 D2 D3 कैलकुलेट करके और उसको राइट हैंड साइड में रखेंगे। फिर x1 x2 x3 फाइंड करेंगे।
फाइंड करेंगे, ठीक है, करेक्ट है। तो फर्स्ट कॉलम कैलकुलेट करके बताओ जरा, ये किस इसका क्या आ रहा है इसमें इनवर्स का? थ्री थ्री क्रॉस थ्री इक्वेशन जहाँ पे सॉल्व करना है, यू हैव योर इनबिल्ट फंक्शन इन योर कैलकुलेटर आल्सो, साइंटिफिक कैलकुलेटर. You may simply put these calculations over there and get the inverse, or get these unknowns x1 x2 and x3. Although your calculator has also this, you can calculate inverse directly from this there. But your calculator will not be able to solve once it is a 4x4 matrix. Okay, so you try this problem. Okay, Abjeet, okay, x1 x1 तो पूरा कॉलम वेक्टर आएगा एक. Okay, x1 x2 you calculate x2 also and x3 also. Okay, so you try it on your own. This LU decompose calculating inverse using this LU decomposition. Okay, so there is one more problem, and this is the inverse for this matrix, and this is the answer for this inverse. And you may, you may also check on your own. Means it should be an identity matrix. So next question is this. This is also an assignment for you. You try it on your own. Next class we will first take up these two problems, because some of you may take more time to solve here. So next class we will take these two problems, then we will proceed towards this further in this topic.
Okay, sir.
You also try this part.
Sir, can you send this PDF up till here?
I'll share you the PDF, but first you try it on your own. Only solving through hand calculation will give you the knowledge about this topic. You may easily put these coefficients in your scientific calculator, and easily your calculator will give you the this inverse of this matrix. But this will not serve the purpose. Okay, so I'll share you these two problems. You solve it using this technique, LU decomposition technique. I'll also share you the PPT. So you solve these two problems. This is the answer for second question. And with this, uh, I'll wait for 5 minutes. Class is over. If we need to discuss anything in today from today's class or the class previous class, so I will wait for 5 minutes. Then we will take all the queries. I'll take all the queries after 5 minutes. If you do not have query and wish to leave, you may please leave. Okay, anything we need to discuss?
Sir, I have one doubt on cost elimination method.
Please tell that.
Yes, sir. Sir, I have the book I follow in that the method, the representation of method is I mean at first they write the augmented matrix form of the matrix, and then they write the pivot multiples on the left side. So sir, I was saying that can we do that method in exam?
Only the way the equations are being represented may differ from your book to book, but you will get the same answer. Okay,
Yes
so
sir.
you may follow any of the method. Okay,
Okay sir.
so yeah. Anyone else? We need to discuss something.
सर बुक कौन सा इसमें यूज
मैं
करूँ?
दूंगा, बुक दूंगा, अभी वेट करो, मैं दूंगा बुक। अगर पहले ही पहुंच जाएगा तो फिर
ओके सर।
अभी, हाँ मैं सब दूंगा, बुक भी दूंगा, नोट्स भी दूंगा, सब कुछ दूंगा, थोड़ा सा वेट करो। ठीक है, ओके। सो
Sir. Hello.
इन द क्लास हियर, थैंक यू ऑल।
Excuse me, sir.
हाँ ध्रुव, प्लीज टेल।
Sir, can you repeat the final steps of matrix formation, inverse matrix formation?
ओके, आई विल रिपीट once more.
Like, what do we multiply with x1, x2, x3 to
Okay,
get?
okay, I repeat this terms. So let us take this problem from beginning itself. So I need to calculate the matrix of inverse of a matrix A, which is given here as 3. These are the some terms here, 3 cross 3 matrix. We need to calculate the matrix of inverse of this matrix.
Yes,
So
sir.
we have decomposed this into two matrix, that is L and U. So these two terms are clear. What is U
Yes, sir.
matrix? What is L matrix? Okay. So what I have done is that I have assumed a right hand side with having one unity in first row, and the rest of the rows it is a, so rest of the terms are 0. So I have calculated a value of d1, d2 and d3 from this lower triangular using this lower triangular matrix. So
Okay, sir.
this from this part, it is second step is that once I get the value of this d1, d2 and d3, I will once again substitute, replace this right hand side with the one obtained for the value of d, and calculate the value of x1, x2 and x3 from here. And the obtained value of x1, x2 and x3 are nothing but the first column of inverse of matrix A. Now in order, I want to calculate this second column of inverse of matrix A. You suggest me what should I do in order to calculate the second column of matrix A?
So multiplying L with, let's say P1, P2, P3 equals to
Uh,
0, 1, 0.
0, 1, 0. From there I will get the value of P1, P2 and P3.
Yeah,
Okay.
and then multiplying U with, let's
With
say X4,
one,
X5,
x1,
X6.
x2, x3, and then we have a known right hand side. From there we will
Yes,
compute the value of x1, x2 and x3. So this will give me what?
second column of the inverse matrix.
Yeah. In a similar manner, we will proceed to calculate the third column of matrix. This matrix. Okay, so we will get this inverse of matrix A, and we will get the third column. So this is how we can, if we wish to cross check our this calculation, we know the process. A into A inverse gives us a identity matrix. Okay.
Yes, sir.
Uh,
Okay, understood.
okay. Anything else we need to discuss? Okay, so I'll end the class here, and I will share you the PPT by evening, and so that you can work on the two problems. Okay.
Okay, thank you, sir.